Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem remove every kth node from the linked list. So let us understand the problem statement and see how we can solve this problem. So the problem says that we'll be given a singly linked list which will consist of n nodes, and we have to do what? We have to remove every kth node from the linked list. So suppose that we have a linked list. Let's say we have got 1, then we have got 2, then we have got 3, then after that we have got 4, then after that we have got 5, and then we have got 6, and then after 6 we have got the next node as null. Okay, if there is a linked list of size 6 and it is having the nodes 1, 2, 3, 4, 5, 6, then null. And suppose the k value has been given to us as what? Suppose k value is 3. So I have to remove every third node. Okay, so in this case what we can do is we can always keep indexing, right? So initially our index would be what? Initially our index will be 1, then for the next node the index will become 2, then for the next node my index will be what? 3. So the moment my index value becomes equal to k, then I can remove that node. Okay, so I will be removing this node and I will connect 2 with 4 instead, because the node 3 indirectly is getting removed. Then after that, whenever index is equal to k, then I can start my indexing from 1 again. So now what I can do is, like, suppose that for this node my indexing will be 1. Okay, for the next node my indexing will be 2, and then for the next node 6 my indexing will be what? 3. Now again my indexing becomes equal to what? K. So then I'll remove this particular node 6, and now 5 will start pointing to null directly because 6 has to get removed. Okay, so you can understand that we will be starting our indexing from 1. Okay, and whenever our index value becomes equal to k, then we will be removing that particular current node. Okay, and after that we'll again start our indexing from 1. So every time the indexing value starts from 1, and whenever it reaches k, so we remove the kth node, and then after that we start the indexing from 1 again for the next set of nodes. Okay, so let's see how we can implement it in terms of code. So basically what we have to do here is, suppose that I'm writing this test case again. We have got 1, then we have got 2, then we have got 3, then we have got 4, let's say we have got 5, 6, and let's take 7 and 8 as well. Okay, then after that next node is null. So what will happen here is, if the k value has been given to us as 3, so we have to remove every third node. Okay, so what I can do is I can always keep a track of the previous and the current node. Okay, why previous and the current node? Because suppose that 3 was my current node. So what do I want? I want my previous node to point to the current next. Understand this thing very carefully, that if I want to remove the third node, and let's say I want to remove the node that is 3, and it is the third node in terms of indexing. So what I want is that my previous node before the current node, if my current node is 3 and I want to remove it, so the previous node that was there, its next should point to the current next. Okay, so the previous next, I want what? I want the previous next to point to the current next, because I want to skip the current guy. I want to remove the current guy indirectly, right? So this is the kind of pointer that I want to change. So initially we'll always be starting from where? We'll be always starting from the head node, right? So we can say that previous node before that would be null. So what we can do here is we can initially mark the previous as what? Null. Initially the previous will be pointing to null because before the starting node there is no node, and my current will start from here. Now my indexing will be 1. At this point my index will be what? My index will be 1. Then after that my current will move forward because the index is not equal to k. Now my index becomes how much? Index becomes 2. So is it equal to k? No. So then my current will move forward and my index will become how much? 3. So obviously I'll keep on moving my previous as well. So let's do one thing. Let's do the complete dry run here. So if you will see here, initially what will happen? Initially my current will be at the node 1 only, and my index value is also 1. So my current is at 1 and my index value is 1. Okay, then after that the index value is not equal to k. So what I will do is I'll say that my previous will now point to current. So my previous will come at the index 1, previous will be equal to the current, and current will move to the current next. So current will point at 2, and index will also increase, so index will become 2. Now is the index equal to k value? No, the index is not equal to k value. So again I want to move forward. Before moving forward I will say that current will behave as the previous. So I will say previous is equal to current, and then current will be equal to what? Current will be equal to current dot next, and my I value will be now 3. Index will be 3. Now is my index value equal to my k value? Yes. Now my index is equal to k. So since the index is equal to k here, then what I will do is I will say that I will mark my previous next equal to what? Previous next is equal to current dot next. Okay, so then what will happen? 2's next would be pointing to 4, and indirectly this connection would be lost, and it can be collected by the help of garbage collection, right? So you can see that we have bypassed this particular connection. Then after this, what will happen next is when my index value becomes equal to k, so I have to restart my indexing. So my index will become 1, okay, and the current guy will behave as the previous. So now 3 will behave as the previous, and now current will be pointing to the element that is 4. Now after this, what will happen here is that when my current is standing here, my index is 1, so index is not equal to k. So again we'll proceed further. So we'll say that now previous will be pointing to the current, so previous will move here and current will point at 5. Now my index will be 2. Then after that my previous will move forward, so previous will be equal to current, okay, and current will move to what? Current will move to the node 6. Now index is 3, so if the index is 3, then what should I do? I should mark previous next as current. So 5's next should be pointing to what? 7. Okay, like basically previous dot next should be pointing to current dot next, because 6 is the node that I want to remove. So that is why the previous node, its next should point to current's next. So 5's next would be 7 here, right? Then after that, since my I is equal to k, so I have to restart my numbering. So what will I do? First of all, previous will be equal to the current, so previous will be pointing to current, and then current will be pointing here. Now my indexing will be what? Indexing will be 1 here. Then after that, what will happen? My current will again move forward because indexing is not same. So before that, previous is equal to current, previous will point to 7 and current will be at 8. Now index is what? 2. So you can see that index is not equal to k. Then after that, when my current will move forward, so I am at null, so we will stop. And you can see that the final linked list will be what? It will be 1, 2, then 4, then we will be having what? Then we'll be having 5, then after that 7, and then 8, and then null. So basically you can understand that now the final linked list that we have removed every third node, because you can see 3 and 6, these two nodes were coming under the category of every kth node, every third node, so they have been removed. And this is how we get our final answer. So I hope that you are clear with this particular logic. If you will see, so we are just iterating through all the n nodes. So our time complexity would be how much? Our time complexity would be nothing but order of n. And are we taking any extra space? No. So the space complexity would be constant, that is order of 1 only. Okay, now let's try and quickly compile this code by writing it first of all. So let's see what we can do here. Also, there is one more edge case that we need to think about. Suppose if the k value was 1. So we have to do what? We have to remove every 1th node. So if you have to remove every node, okay, if you have to remove the first node, then second node, then third, every node if you have to remove. So then you will say that the linked list will not be existing, right? Because if you have to remove every second node, if k value is 2, so you'll remove every second node. But if k value is 1, then you'll remove every node one by one. So the linked list would be null. So this is how we can check it. Now let's try and write one more base case. So what will happen is, suppose that if my head is what? If my head value is equal to null. If my head is null, then what can I say? If the head is null, then we will directly return null. Okay. Otherwise, suppose that what happens is, another case is that if my k value is 1. If my k value is 1, so I have to remove every first node. Like basically I have to remove every node in that case. So my linked list would be empty and I'll return null. So let me just write capital null here, because in C++ null is indicated by capital case. Okay. So I'm writing this here. Now after this, what I will do here is, I will first of all declare a previous variable and a current variable. So let's say I will declare node star. Let's say previous is equal to null, because initially previous will be not pointing anywhere. Then after that, node star current, and the current will be pointing to what? Head of the linked list. Then after that, what we will do is, we'll say that while the current node, until the time it is not equal to null, till that point of time we'll iterate. Okay. And what are we going to check? So we need to have one indexing variable. So let's say I can take int index is equal to, let's say 1. So initially I'm going to start my index from where? 1. Now after that, I will check that, suppose that if my index value is equal to k, then what can I do? If my index value is equal to k, then as I said, my previous next will be pointing to what? Current next, because I want to skip the current element. Okay. Then after that, we will move our current forward. So we'll say that current will be equal to current's next, because we'll move by one node. Okay. And for the next node, the indexing will start from where? The indexing for the next node will start from 1, because if the current node that we are at, if it is equal to k, if its value is equal to k, if it is the kth node, then we will do what? We will remove the current node. So that is why the previous next would be pointing to current next, and then the current will move forward to the next node as we do normally. And then after that, for the next node, we will start the indexing from 1. Otherwise, what we will do is, if suppose that the current node that we are at, if it is not the kth node, then we will do what? Then we need to do index plus plus, and at the same time we will do what? We will do current is equal to currents next here. Okay. And then at the end of the day, we can simply return our head of the updated linked list. Okay. So let's try and quickly compile this code to check if it is working fine or not, and see what happens. Okay. So we are having one issue here. Let's check this now. So basically, if the head is null, that is what I'm checking, then I'm returning null only. So there is some mistake, like it says that L value requires as left operand assignment. Okay, so let's do one thing. Let's remove this condition from here, and then after that what we'll do is, if the k value suppose was 1, okay, then we will return null here. So let's just make this fix and now check. Okay, so if the head is null, then I'm returning null, or if the k value is 1, then also I'm returning null. Else what I'm doing is, I have marked my previous as null, then current will be pointing to the head, that is also fine. Then after that what we do is, if the index is equal to k, then I'm marking the previous next to the current next, and current is equal to current dot next, and then index will start from 1. Else I'm doing index plus plus. Yeah, so I've not done one thing, like when I'm updating, so previous will be pointing to current, because if the current node that I'm at, if it is not equal to the kth node, okay, so then I'll increase its indexing, and then I'll say that the current node will behave as the previous node and current node will move forward. So I was missing this line number 69 there. Okay, now let's try and compile it, and it would work fine. Let's submit it. So you can clearly see that our code was able to pass all the test cases. There was only one small mistake that I had made in the line number 69, where I was not writing previous is equal to current, because whenever I'm at a particular node who is not the kth node, then in that case what I have to do is, I have to mark my previous as current, and then current is equal to current dot next here. Okay, I hope that you have understood this problem clearly. Please make sure to comment understood or +1 in the chat if you have understood it clearly, and thank you for watching this video. Keep coding, guys.